Welcome.
Welcome to the Mixed Reality Training for Atomic Force Microscopy. Before we begin, we will go over some basics for using mixed reality. By now, you should be wearing the Quest 3 headset. If at any point you feel uncomfortable, you may take it off and choose not to continue. There will be no negative consequences if you should need to do so. Feel free to adjust the interpupillary distance of the lenses to suit your eyes by using the dial on the bottom left of the headset. Similarly, you can adjust the volume using the controls on the right side of the headset. You may proceed through the training at your own pace. In mixed reality, there are virtual menus and objects that you can interact with using your hands or the Quest 3 controllers according to your preference. If you turn either of your palms or controllers upwards, you should see a menu open up. In this menu, you should keep the pass-through option enabled to prevent accidentally walking into something. You can also use this menu to navigate forward and backward in the training. There is a navigation panel on the left that allows you to move between sections. You cannot jump ahead until you've finished each section, but you may always repeat or go back to any previous section. For this training, you will need to interact with virtual objects. If you're using your hands, I recommend keeping your palm open when pointing or selecting. This helps the software track your hand better. You can use your pointer finger to select buttons, and you can use your thumb and pointer fingers to grab objects, rotate them, and move them. Try doing this now with the items on your right. If an object is too far away to select or grab, you can point at it with both your thumb and your pointer finger to activate the remote function. Once activated, pinching your thumb and pointer finger will select. Pinching and holding will grab. Go ahead and try this. You can also grab some objects with two hands. While holding on, you can move your hands closer or farther apart to zoom it. If you prefer to use the controllers, the functionality is the same. Here the remote function is always activated and is indicated by the circular dot. Selecting can be done with the pointer finger trigger. Grabbing can be done with the middle finger trigger. Similarly, you can move, rotate, and zoom objects. Try doing this with the items on your right. Once you're comfortable with this space and interacting with objects, feel free to move to the next section using the navigation panel on the left. Training overview. Today we're focusing on a small but critical part of AFM operation, the setup phase. That includes handling the enclosure, mounting the probe, installing the AFM head, and reviewing alignment using the software interface. In the mixed reality portion, you will not be interacting with the actual equipment. Some sections will predominantly be listening to me, but most sections will involve 3D models that you can interact with. After you complete this portion in mixed reality, you will be able to practice doing them with the actual equipment. Glove fitting. The gloves can be found mounted on the wall to the left side of the lab door entrance. Here's a tip. When working with the probes and mounting the probe holder on the AFM head, we recommend wearing tighter fitting gloves. That way, you won't have extra glove material bunched up at your fingertips, which makes it easier to place the probe and the probe holder on the AFM head precisely. In this section, we'll learn how to open the AFM enclosure door. The Allen key can be used to unlock the door, which you will do in a later stage. Make sure to turn it fully counterclockwise to unlock the door. Opening the enclosure door. This door has a unique two-hinge design. It doesn't swing out like a cabinet door. It lifts upward with the bottom part staying relatively vertical. You will want to lift it all the way up until it clears the front edge and then push it all the way back. That'll make it easier for you to lean inside the hood and look over the top of the AFM dovetail if needed. Be careful not to let the door bump into the soundproofing strips on the way up. Once the door is opened, remove the Allen key from the lock and lay it inside the AFM enclosure besides the AFM on the left-hand side of the air table so that you're not bumping into it. Inside the enclosure, you will see the AFM. We also refer to the AFM as the Bruker dimension icon, the Bruker icon, or simply AFM. Probe orientation and handling. The probes themselves are very delicate, but the chip that the probes are fabricated on is not. Don't be afraid to pick up the probe with tweezers. You don't want to be holding them so lightly that you're dropping them often. It is important to understand the probe geometry so you can identify the correct orientation for mounting the probes in the probe holder. The front side with the cantilever has 3 angled edges, while the back has just 2 rectangular 90-degree corners. The back side will sit in the bottom of the probe holder channel when mounted correctly. The top and bottom of the probes also look very different. The bottom often has a reflective aluminum coating to increase the signal reflecting off the probe, while the top is bare silicon or silicon nitride. Some probes have both front and backside coatings for various other AFM applications. Details of the probe coatings can be found on the label of the probe box. The top of the probe also has an etched Bruker logo, which gives it some texture that you can grip with tweezers for small manipulations within the probe holder. The top must be faced up when mounted correctly. The probe also has a slight bevel on the sides. The top is slightly larger than the bottom, and the sides are sloped, making the side profile of the probe trapezoidal. This is to make it easier to pick up the probe when it is facing the right side upwards. Conversely, this makes it harder to pick up when it is upside down. If the probe is flipped upside down, the cantilever is likely damaged and you'll need a new probe. The probe cantilevers are extremely fragile, and even brushing against your glove is enough to break them. Each probe costs from as cheap as $15 a probe to as expensive as $4,000 a probe. Typical topography probes are about $30, so it's not very expensive to lose a probe now and then, but repeatedly breaking them or dropping them can add up. Now you may spend some time interacting with the model of the AFM probe. Make sure to observe the probe geometry and features. As a reminder, the probe is not modeled to scale since the cantilever is much smaller than shown, but you can move, rotate, and zoom the model as you choose. The cantilever and the tip are an integral part of the AFM used to measure the topography and other properties of the sample surface. Both the cantilever and the tip come in many shapes and sizes, each with pros and cons for specific applications. Details of the cantilever dimensions, tip dimensions, and coatings can be found on the probe box label and the vendor websites. While AFM cantilevers can vary in shape and size, the chips that they are fabricated on are mostly universal in size and shape. The probes we use are mostly rectangular, except for the front side, which has a 3 angled edges to help you identify which side is the cantilever side. The beveled side of the probe make the top surface of the probe slightly wider than the bottom. This creates a trapezoidal side profile, which helps the tweezers grasp the probe when it is facing the correct side up. It is common to have coatings applied to the AFM cantilever and tip. For topography applications, the back side often has a reflective aluminum coating to increase the signal reflecting off the back side of the probe, while the front is bare silicon or silicon nitride, including the tip. Probe coatings can vary depending on the AFM application. Details about the coatings applied to the front and back sides can be found on the label of the probe box and vendor websites. The probe mounting station is a black cylindrical part that you should find either on the raised platform portion of the right side of the AFM or on the computer desk. It has 3 different probe holder positions for different types of AFM probe holders. The standard probe holder position has extra flat platforms to keep it held flat during the mounting process. The fluid probe holder does not have the extra flat platforms, but instead has a bar strap for pushing on a spring plate. Working in fluid requires a completely different mounting method, which is a very different probe holder design. The third position is for the electrical probe holder and has none of the extra flat platform material and nothing special about it. It's wide open because of the shape of the electrical probe holder. Otherwise, it has the same mounting mechanism as the standard probe holder. We will be using the standard probe holder position, which looks the strangest and should be the easiest to remember. Some people think it looks weird and try to avoid it, but it should be the opposite of that. The brass pins on the probe station are the same pattern as the pins on the bottom of the AFM head. When you look at the probe holder, you will see 4 holes that line up with these pins. The brass pins are very soft and delicate and are easily bent or broken, so be careful when handling the AFM head and the probe station. Mounting the probe. There are 2 tweezers in each AFM enclosure. The straight flat ones are for samples. The curved sharp ones are for mounting the AFM probes. Please do not use the curved sharp tweezers for sample handling. Before you pick up the probe, rotate the case of 10 probes so that the probe you want is in the right orientation for loading. When gripping the probe, don't hold too tightly or too softly. If you're not dropping it or crushing it, you're doing it right. The probe goes into the recessed channel on the probe holder. It should sit parallel to the side walls of the channel. It's easy to get it tilted or crooked. You can use the tweezers to nudge the probe into position by placing the points in the etched writing on the top of the probe and gently dragging it into position. Be careful if you do this because the probe can easily get flipped out of the channel and broken. Another option is to gently tap the probe station on the table to get the probe to fall into place. There are tiny little cutouts in the back of the probe holder channel. These are for the tweezer tips to come in and grasp the probe when you're removing it. When manipulating AFM probes, it helps to stabilize your hand by resting your arm on the table and several fingers on the probe station side for balance to help reduce shaking. Once the probe is in, we'll use the sliding clip to hold it in place. Push down and slide the clip gently all the way forward and rest it centered on the AFM probe. Some people do this with one finger, some people use two. Find what works for you. Now that we've covered the probes, the probe holder, and the probe station, take some time to examine each of the models and how they relate to each other. Note that these models are not scaled to each other. In reality, the probe is about the size of a grain of rice. There are 4 holes on the probe holder. The sides do not have the same spacing, and the hole layout matches that of the brass pin layout on the AFM head and the probe mounting station. This leaves only one way to mount the probe holder on either. The rectangular recess on the probe holder is the probe channel where the probe sits. The channel has a 15-degree angle to it. This helps the probe slide into position at the bottom of the channel when you tap the probe station gently on the table. There are 2 circular cutouts at the back of the channel to allow the tweezers to come in and grasp the probe when removing it. The sliding finger clip is used to hold the probe securely in place once it's been inserted correctly into the probe holder channel. There really isn't a middle position. It's either all the way forward when holding the probe in place or all the way back when removing the probe. The rectangular recess on the probe. We now move to the AFM enclosure. In this section, you will learn the features and function of the Bruker dimension icon and how you should handle the AFM head. This is the Bruker dimension icon atomic force microscope. It consists of the enclosure, the AFM head, the AFM stage, the AFM optics, the granite base, and the working area on the right side. There are 3 common ways for the system to be damaged by a user: mishandling the AFM head during probe mounting, placing anything on the granite surface and navigating, or navigating in X and Y without enough clearance in Z so the AFM head runs into something. The AFM head is one of the most delicate and expensive components of the AFM. A common way it gets broken is by dropping it or not paying attention to the brass pins on the end of the scanner and hitting them into anything. The handle makes it harder to drop, but it is up to the user to pay attention and protect the AFM head while it is in their hands. It is not okay for the pins on the end of the AFM head to touch anything other than the probe holder being mounted. Damage to the AFM head could cost between $10,000 to $50,000 to repair, or even up to $75,000 for replacement. Our most common way the AFM gets damaged is when the stage moves across the granite surface and runs into something that was left on there, such as sample containers, probe station, or tweezers. It is never okay to put anything on the granite. The AFM stage uses the entirety of that granite surface for moving in X and Y. Use the raised working area on the right of the AFM or the AFM computer table to place anything you need for your work. Another way the AFM can be damaged is when there is a thick or tall sample on the stage. It is possible to crash the AFM head into a sample when it is on the stage and the user is navigating in X and Y without enough Z clearance. To avoid this, you need to use an exaggerated motion when moving the stage. First, raise the head much higher than the sample in Z in the software. Then move the stage in X and Y while there's no danger of collision. And when you're in position above your sample, Z down to the focus position. Before lifting the AFM head out, make sure the area is clear. Next, unscrew the thumb screw just a few turns. Notice that the AFM head is mounted in a dovetail slot. It has very, very, very tight tolerances, which means that it needs to be lifted straight up, vertically, like an elevator. While lifting, if you introduce even slight rotations about any axis, the AFM head will not lift up. Because of the weight of the AFM head, approximately 2 pounds, and where you're holding it, there is a natural tendency for it to rotate away from you. To compensate for this, you have to rotate your wrist slightly towards you while lifting, similar to how you would rotate a bike handle throttle. Another option is to use your other hand to gently push near the bottom of the AFM head to counter this rotation. The AFM head should move upwards smoothly and quietly without too much effort. If that is not happening and the whole table is shifting when you try to lift the head, you need to adjust your technique. Now that we've gone over the process, take a look at the AFM and orient yourself to the relevant parts. It might be helpful to zoom into the model to make it easier to select distinct elements. The Allen key is used to lock and unlock the AFM enclosure door. The key turns approximately 270 degrees to fully unlock or lock the AFM enclosure. While you are working with the open AFM door, it is convenient to remove the key and lay it on the left side of the air table so that you're not bumping into it. The air table provides a cushion of compressed air to further isolate the AFM from external vibrations. The granite surface is intentionally heavy to dampen external vibrations and isolate the AFM. Be careful never to place anything on the granite surface. Anything left on the surface can get jammed between the stage and the AFM protective skirt and damage the stage and the XY motors. The AFM stage is moved with X and Y mechanical motors. Samples are mounted on the stage, usually in the center vacuum chuck position, and then moved into position using a combination of the trackball and navigation section of the Bruker software. The laser optics and camera objective are located on the left side of the AFM head and stage. These components are fragile and their alignment is critical. No fingers can go on the left side of the AFM head or under the AFM head near the brass pins unless you are specifically loading the probe holder on the AFM head. The AFM handle is used to hold the AFM for probe holder mounting and unmounting. A solid grip is needed at all times, and care of where the AFM head is in space needs to be used while the AFM head is in the user's hands. Mishandling the AFM head is one of the most common sources of user damage to the AFM. The body of the Bruker dimension icon has a dovetail. The back of the AFM head has a dovetail insert that fits into this channel. The tolerances between the channel and the insert are very small. This makes lifting the AFM head out of the channel difficult unless done near perfectly. The thumb screw secures the AFM head in place so that it does not move around while scanning. To lock the AFM head in place, turn the thumb screw clockwise until it is finger tight. Turn the thumb screw counterclockwise several turns to release the AFM head to be able to lift it. Continuing to turn the thumb screw past several turns should be avoided as you risk removing the thumb screw completely. This cable has all the wiring for the power and control of the AFM head. The cable is rather short and stiff, so you don't have a lot of play with the AFM once it's in your hand. Be careful not to twist or strain the cable too much. The brass pins on the probe station are the same pattern as the pins on the bottom of the AFM head. When you look at the probe holder, you will see 4 holes that line up with these pins. The brass pins are very soft and delicate and are easily bent or broken, so be careful when handling the AFM head and the probe station. The raised platform space on the right side of the Bruker icon can be used to place tweezers, samples, and the probe station. This is to prevent anything from being placed on the granite surface. The granite surface, the Allen key is used. The air table provides. We will now go over the process for mounting a probe holder on the AFM head. Before proceeding, you may find it helpful to look over the models to help you follow along. Mounting the probe holder onto the AFM head. Turn the head over gently and you'll see 4 brass pins. They bend easily, so be careful to keep them clear of all surfaces while the AFM head is in your hand. The entire circular area on the bottom of the AFM head is connected to the piezo scanner, so any impact will damage both the pins and the piezos. The probe holder pins must match the AFM head pin alignment. Notice the pins on each side of the probe holder are not the same distance apart. To make mounting easier, rotate the probe station so that the probe holder lines up with the pin orientation on the AFM head. Use a crab claw grip with the very tips of your fingers to avoid touching the cantilever and having your fingers get in the way when trying to mount on the AFM head.
Gently place the probe holder onto the head and lightly push down onto the pins, making sure it is all the way to the base of the pins and mounted flat. It might help to look at the pins from an underside angle to make aligning the pins with the probe holder holes easier. To replace the AFM head, lean into the enclosure and above the AFM. This will help you align the dovetail in the slot. As you lower the AFM head, don't let go too early. You need to lower it all the way down until the line at the back of the dovetail mount is approximately at the same level as the top of the AFM head. Sometimes it will wedge halfway down and stop moving, and it's easy to think that it's all the way down at the bottom. Falling down into place can be enough impact to damage the AFM head. Closing the enclosure door. Once the head is installed, we'll close the door. Lower the AFM door carefully without smashing it into our soundproofing as you come down. We want to avoid rubbing the door against the soundproofing foam as that tears easily. That's why it's covered in tape. Grab the door bar with both hands. Lower it down slowly while watching the edges. And place your right hand at the top of the first hinge when it's comfortable for you to do so, and use it to press down and hold the top section firmly in place. Bring the bottom section of the door all the way down and lean on it to minimize the gap at the bottom of the AFM door. If you let up at all on the pressure on the handle of the door, it will rise up and the hook will not grab. Turn the Allen key fully to lock it. It turns about 270 degrees to close and open. If you're having any trouble turning the Allen key, there is likely too much of a gap and you'll need to redo setting the door properly into place. Getting the door closed correctly is important because the system is very sensitive to sound and it needs to be tightly closed to isolate it from all external lab sounds.
We will now spend time practicing the main tasks in mixed reality. In this section, you will need to complete virtual versions of the steps done in loading an AFM probe onto the AFM. If you're having trouble, there will be some hints and tips that will prompt you in the right direction. Each section can be done repeatedly, and you are encouraged to repeat sections until you are comfortable with the process. The first step is to unlock the AFM enclosure door. You will be able to interact with the Allen key on the enclosure door to unlock it. Once you are done unlocking it, you will automatically move to the next phase, but feel free to come back to it and repeat it. As a hint, don't try to grab the key as you would a physical key. Simply use 2 fingers or the trigger of your controller. Next, you will need to lift the AFM door up and over the top lip of the enclosure. Now we will practice identifying the correct probe orientation. You will need to align each of these probes so that the top of the probe is facing upwards and the cantilever is pointing to the left. For this task, you will need to place the probe into the probe channel correctly and secure it with the sliding clip. Make sure to align the probe correctly in the channel before securing it with the sliding clip.
Lifting the AFM head is the hardest part of learning to set up the icon. For this task, you will need to grasp the AFM head handle with your left hand and lift it vertically. The AFM head will not move if you are introducing any unwanted motion or rotation, so pay attention to the floating coordinate axes that provide feedback on how you are moving the AFM head. Now that the probe has been loaded into the probe holder and you've lifted the AFM head out, the probe holder can be mounted to the AFM head. For this task, you should only use your right hand to mimic the real task. Carefully remove the probe holder from the probe station and place it on the pins you see on the AFM head. Finally, you will need to shut the enclosure door and lock it. Remember to use both hands while pulling the door down. You have now completed the mixed reality portion of the AFM training. However, you may go back and redo any of the sections if you choose. When you are done, simply take off the headset to continue with the practical portion.